So, hello everyone. Today we have Astha with us for the mock interview. So, let's start. So, Astha, can you quickly give us a brief introduction about yourself? Like, what do you do?
Yeah, so hi everyone, I'm Astha and I'm currently in third year of BTech from Maharaja Agrasen Institute of Technology, and I have a keen interest in problem solving and also exploring the web development side right now. Yeah, so
Okay.
that's all about me.
So, Astha, as you mentioned, web development. So, have you had some experience in web development? What do you work? Like, what frameworks do you use and everything?
Okay, so yeah, I use React, like mostly in React and front end development. And talking about my experience, I was the part of the Microsoft Engage program 2021. So I was a mentee
Mm-hmm.
there. So I have made the project of the MS Teams clone.
Just one second.
Like it has the functionality of video chat between two people and all that.
Okay. Okay. So, you must have used web sockets and everything, right?
Yeah.
So, can you tell me what web sockets exactly are and how do they work, basically?
Yeah, okay. So, WebSockets basically they help us in building connections between like peer-to-peer connections, and yeah, they help us in doing peer-to-peer connections, and like they are present in React, and yeah.
Okay, so as you're mentioning React, do you have any clue what functional components are?
Okay, so functional components are basically the functions that we write in the React, we can say action listener, event listener, and also specifying the function, what it does, and catching errors and all that.
Okay, so like why do we use functional components, not class components? Any clue?
No, I don't have that.
Okay, okay, fine. So, Astha, I'll quickly start with the DSA questions. So, what I'll do is I'll give you the link to the doc and you can present your screen and you can just write the function of that code. No need to write everything, you can just write the function of it. Okay,
Okay,
cool. So, I'll just share the doc with you in the chat and meanwhile,
okay,
you can share your screen.
sure. Is my screen visible?
Just one second. Yes, your screen is visible.
Okay.
Yeah, so you can open Google Docs on your like laptop only, and I'll just tell you what the question is.
Okay, I can't see the doc in the chat.
No, no, you can open the doc in your
Okay,
laptop
okay.
only.
I can
Yeah,
open. Sure.
yeah, cool. So the first question that I'm giving you is: suppose there is a matrix that I've given you. It is a two-dimensional
Okay.
matrix, and you have to
Okay.
find the kth smallest number in that particular matrix. Okay. For example, like,
Okay.
did you understand the question? There's a 3D matrix. For example, there is 1, 2, 3, 4, 5, 6. Right?
Okay.
Can you write for me?
Yeah, sure.
1, 2, 3, 4, 5. Next row. Next row. 1, 2, 3 is one row. 4, 5, 6 is another row.
Okay, sorry.
Yeah, no problem.
Yeah.
Suppose this is the matrix and I ask you to
Okay.
find the third smallest number. So, what will be your answer
Three.
according to you? 3, right?
Yeah, it
So,
will be three.
similarly, user can enter any number. Suppose I enter the first smallest number. So, the answer would be 1. So,
One.
similarly, there would be a matrix. M and N would be given to you, or a matrix would be inputted, and there would be a K.
Okay.
And you have to return me that particular number. So, yeah.
Okay. Uh, okay. So, like matrix will be sorted. Is there any constraint on
No, no.
like row wise sorted or column wise sorted or anything?
No, it is nothing like that. Like matrix can be anything. Like in this situation, the matrix is sorted, but
Yeah.
DSA matrix can be of any order and anything.
Okay.
Yeah,
Uh, we have given a 2D matrix and we have to find the kth smallest element. Okay, so
yeah.
for finding the I think kth smallest element, I can use a priority queue. What I'll do is I'll go through all the numbers and I will add them in the priority queue and will take out the smallest element in that. That will take time complexity of O of n square, like O of m into n, since the matrix is m cross n.
Okay.
Uh, and
So
if
why did you
I,
use
yeah,
a priority queue? Can you like tell me the thought process behind it? Like how did priority queue like came into your thought?
yeah, because we know that when we use a priority queue or a heap, when we like it is there to sort the elements, and since the question is saying to find the case smallest element, so we can easily do that. And also uh, I was thinking like to improve upon it, what can I do since it is taking the polynomial
But
time.
priority queue is not to sort the element. Like it is to
Yeah,
tell us like the if it is a like min heap, so the minimum number like from all will come at the top, right? And if it is a max
yeah,
heap, then the
yeah.
maximum number. So it doesn't sort the element in any scenario.
Yeah, like I mean to say that when if I put all the elements in the priority queue and when I take out the elements, so and like if I store them, so I will get them in the sorted order, right? Like reverse sorted or normally
Okay.
sorted, depending on
Can
the
you
type
just
of the
dry run
particle.
whatever you're trying to say in this particular test case? 1, 2, 3, 4, 5, 6. Or you can take any other test case also if you want to.
Okay, so if I do it on this test case, so what I'll do, my priority queue will look like I'll add all the elements in the priority queue and will take out the k minus. Like the question was here to
Suppose
find the
K is 2.
k is 2. Okay, since k is 2. Okay, so what I can do is I can take out the k minus 1 elements and I will print the or I will return the kth element. If I take
You said
another
you will
example.
take K minus 1 element. So K minus 1 is 1. So you are
Yeah,
saying that you
I'll remove the first element and then I'll see to the priority queue that what is the next element you have in your peak. Since it is a min priority queue, I'm taking the min priority queue, so it will give me 2, which is our required since k is 2.
so for finding the smallest element, you are saying that here you are finding the minimum priority queue, right? Min
Yes,
heap.
I'm using the min priority queue. Yeah.
Okay. So I did not get it. Like, can you dry run? Like till here I got it. Like 1, 2, 3, 4, 5, 6. It will be there in your heap, and one would be at the
Yeah.
top, right? And now K is 2.
Yeah.
Now after that, what will happen?
Yeah, one will be at top, and then what I'll do is I'll take a for loop and I'll remove the like. Let me take k is equals to 3, then I can tell
Cool.
better. Since k
No
is
problem.
3, what I'll do is I'll take a for loop and I'll remove the elements. I'll remove the elements from the priority queue. Like I'll remove the top k minus 1 elements from the priority queue. So the next element which I'll get is the kth smallest element, which is the required. So what I do is I return that element, like which will be the peak of the priority queue.
Yeah, cool. So, like whatever you're saying, can you show this in this example? You're saying that you will remove after k minus 1 element. Suppose k is 3.
Yeah.
Now,
So
what will be the next step?
yeah.
Yeah.
So I'll remove one. So my next will be this, then I'll remove 2, so next, so my priority queue will look like this, and then what I'll do is I'll return this element
Okay,
or
but
print.
you know that in a priority queue, like in this situation, the elements are sorted, but in a priority
Yeah.
queue, it is not like the elements, like it is not like it will, if it is a min heap, it will store like 1 2 3 4 5 6. One would be at the top, but there is no guarantee that the other elements 2 3 4 5 6 would be in order, right?
No. Okay. So let me take another
Yeah,
example which will not be sorted. Okay.
right.
Yeah. Okay. So we have this example, and let's suppose k is 3. Okay. So in this, our answer should be 4, right? We have
Third,
to,
yes.
yeah. So our answer should be 4 because we have to print the third smallest element. So what I'll do is I'll add all the elements in my priority queue. So that will be 4, 6, 4, 3, 7, 8, 5, and 2. Okay. So since this is my priority queue, I'm adding all my elements in the priority queue. Then what I'll do is
And
I'll,
2 would be at the
uh,
top if it is a min heap,
yeah,
right? Hmm.
yeah. Since it is a min heap, then it will store it as, like, 2 will be at top. Okay, I'm not writing that.
Right.
2 will be at top. So what I'll do is I'll take out k minus 1 elements. That is, I'll take out 2 and I'll discard. Like, I'll remove it from the priority queue. Then my priority queue will look like this: 4, 3, 7, 8, and 5 with 3 at the top. Then
Okay.
yeah. So here my I is 0. Here my I will be 1 when I'm taking out the elements. Okay.
Okay.
I'll yeah. So I have to take the k minus 1 elements out. So my next step will be my priority. While my I is 1, I'll remove 3, and my priority queue will look like 4, 7, 8, and 5. Then here my I is 2, which if I increment my I, then it will go beyond the limit, so I won't remove
Mm-hmm.
anything. So my final priority queue is this. And then
Okay.
what I'll have at the top of my priority queue is 4, which is our third smallest element, which is like required to us.
Hmm. Okay. I got your approach. You will get an answer with this. But can you optimize this approach further? Is it even possible?
Okay. Hmm. Okay. So these aren't given to us as sorted. Mm. To find the k's smallest element, what I can use.
First of all, can you tell me the time complexity of this particular code, like whatever you have written till now?
Yeah, it will be O of m cross n, because I'm iterating through the whole uh, 2D array once.
You're
So it
iterating
will
through the
be
whole 2D array once and you're storing all the elements in your priority queue, right?
priority queue. Yeah.
Okay.
So it will also have the space complexity. Um, to further optimize it, what I can do is mm, for using binary search, I have to like sort it first. Mm, Um, okay, I'm thinking what I can do.
Yeah, yeah, take your time. If you can think out loud, it'll be better. Like what you're thinking,
Yeah.
can you tell me so that I can also guide you if you're going in the right direction?
Yeah. I was thinking if I can use the like maybe binary search or something,
Okay.
but for that we
Just
need
think
sorted elements.
in the form of size of the heap. Just stay on heap and just see if you can reduce the size of the heap
Size
through
complexity.
any means. Right.
Okay. Hmm. Okay, to like to reduce the size, what I can do is I can store the first k elements in heap and then check which is the smallest among them. I guess I can do so for the every k parts. Like for this, if I take 4, 3, and 7 first, so I'll ask, but that won't be the okay. Hmm, just a second. Instead of having every element on the priority queue, we can do is I can take out the if I store first k elements in the priority queue, then 437. But that won't do any good to me. Uh, I remove the smallest element in that. So there could be a possibility that the I have one here. Then the answer won't be coming right. I was thinking if I could store k or first k or k plus one elements, like if I can divide my array in the parts and store k elements in that.
And
I can
store
try.
key elements in that. Uh, I don't really think that will work. Just try to reduce
Yeah.
and like apart from min heap, like okay, I will give you a hint, and I think this will work. Maybe try using max heap instead of min heap, and then try solving the question.
Okay. Mm, if I use max heap, then if I store all the elements in the max heap, then I have to iterate over n minus like if total elements are I'm considering as n total number of elements, then I have to iterate over it for n minus k times, which will increase my complexity. Um, and if I store first k elements in the max heap, then it will give me the max element, right? So if I store 437 in the max heap, then it will give me 7. Then I can add 8 to give me 8. Okay. Hmm, let me try it. So
Try
I
it with max
can,
heap. Try doing
yeah,
something with max heap.
yeah. So it's 7, 5, 4, 3, and 2. This will be there in the max heap, like in this order. So,
You can take the matrix to be sorted. If you have
okay,
to assume, just assume that the matrix is sorted. It will make things easier.
okay. So if this will be sorted, then 2, 3, 4, 5, 7, and 8. Okay. Okay. So I'm considering matrix to be sorted. Then okay. So if I consider matrix to be sorted, then I don't need even priority queue. Like I can just iterate over them and have a different, like we can say a flag or pointer, and I can say if that if that is equal to k, like if in this case I have to return the uh, like my k is 4, so I'll iterate over it and see
But
if
it is row
uh,
wise and column wise sorted. Like it is like 10, 20, 30,
okay,
40. Then it can be 15, 25, 35, 45, like that. So, for example, if that is the case, suppose it is 10, 20, 30, 40. Can you write as I say?
yeah,
Yeah, suppose it is 10, 20, 30, 40. Then 15. Next row 15,
yeah,
25, 35, 45. Then 24, 29, 37, 48. Then 32, 33, 39, and 50. Okay, so what would be the output according to you? If you have to find the third smallest number.
okay. What you said in the last row, can you repeat?
Okay,
20,
32, 33, 39, 50.
okay. Okay, so and my k is
And K is 3, third smallest number.
okay.
Yeah,
Okay, so then the answer will be 20.
20,
Okay.
right?
Mm-hmm.
Yeah.
Yeah. Okay, so it is given, it is row wise sorted. Mm. And I have to find the k smallest element. Okay. Mm.
Maybe like you try using maximum heap, and then like just try storing the k elements in that and see what you
Yeah,
will get out of that. Just dry run maybe.
yeah. Okay, so if I use a max heap, um, and okay, and that, then 30, and I will since it is a max heap, so 30 will be at the top, and I'll remove it. I'll remove it. Hmm. I'll remove it since it is the I'll add 40 in that. I'll remove the 40, and if I write 15 in that, then my 20 will be at the top, and then 25 will be at the top. Hmm. I'm not getting exactly. Like
Okay,
I
no
am.
problem. Yeah, see, no problem. Like you explained me the previous approach, you can like quickly code down that approach. I think that will also work.
Okay with the min heap, right?
Right. Min heap also you can
Okay.
do the same question with max heap as well. So if you want to try that out, you can try that as well. But yeah,
Okay.
I think using max heap would be a better option if you see. Because see what you will do is you will store all the elements in the max heap. So what will it be? Like the top element would be like for example, if I tell you, I just take
Yeah.
an example. So first of all, what you will do is you will store all the elements in the max heap, and then what you can do is you can run a while loop till it is greater than k, till the size of p, like suppose the size of my heap is 6, and you can run the loop till the size is greater than 3. So it will remove all the elements, and automatically the element at the top would be the greatest element, but it will be the smallest element from the start. Like if you take it like
Yeah.
max heap ke form mein.
Yeah. I understood.
You understood what I'm
Like
trying to say?
yeah. Yeah,
Yes.
but I will take more operations because let's take this as example,
Mm-hmm.
3, 4, 5, 6, and if I put my k as 2, suppose. Okay, so if I put all in the min heap, and then if I remove first element, then my element will be 2, which is required, and I'll get it in the first like after the first iteration, right? And if I put them in it in the max heap, and then I have to like remove 3, 4, and 5 and 6. So I think it will not
Yeah,
in
so
the
in
terms
this
of
case,
time.
you have taken two, right? So it is taking more operation. But what if I take six? Like, for example, if I take the sixth
Yeah,
smallest number, so it will take less operations.
yeah,
So in either case,
yeah,
like there would be it
yeah,
will
yeah.
depend on the
I
question.
understood that.
But yeah, you can use
Hmm.
either and quickly quote the your
Yeah,
approach.
sure. So,
You can write the function directly.
yeah, sure. Mhm. Let me take the function as smallest number. Okay, and I'll be given the array, and let's suppose I'm given the uh, n cross m,
Okay.
right? Uh, I'll make a priority queue of integers, like let me
So
take
you
as
using Meep or
q.
Maxheap? What are you using?
I use maxi, right?
You'll use Maxheap core.
Yeah, priority queue. And for the max heap, I have to write collections dot reverse order, since uh, min heap is the default one, right? And then I'll iterate over all the elements. Uh, and I'll add all the elements in the priority queue. Okay, so uh, next I will do is I'll iterate over the priority queue for um, okay, I'll take the while loop. It will be better. Till our priority queue dot size is okay. Case two, priority queue will be having 6 elements. So till my priority queue's size is greater than k, I'll remove the elements from the priority queue, and then I'll return priority queue at peak. So since my priority queue size is 6, less than priority queue k, less than k, so it will be 6, so 5, 4, and then 3, and then 2 is not less than k. It will remove and it will return. Yeah,
Are you sure this will work? Just check your while statement once.
sure. Less than k. Uh, 6, 3. Mm-hmm. It will be greater than k, because
Why?
for 5, yeah, because since it's in starting it's 6. If I take the example of 1, 2, 3, 4, 5, 6, and my k is 2, so when the size reduces it will be 5, then 4, then 3, and then it will be 2. So since 2 is not greater than k, it the while loop will terminate, and uh, whatever is at the peak, the priority queue will return that.
Okay, can you quickly run this code for 1, 2, 3, 4, 5, 6?
Okay.
Next row.
Yeah. So okay, sure.
Yeah.
Yeah. So my priority queue will be 1, 2, 3, 4, 5 and 6. So my priority queue will be this after
So 6 is at the
addition
top,
of,
right? You're taking max heap.
yeah, 6 will be at the top.
Cool.
So 6 will be at the top. Then my when 6 will be at the top, my priority queue size will be 6. And since my case, I'm taking k. Let me take k as 2. Okay.
Yes.
So hmm, it is 6. My size of priority queue is 6. Then it will remove the 6 from here. So 6 will be removed, and then
Yeah,
5
just
will be
remove
at
6.
the,
Remove 6.
okay. Then
Yeah.
5 will be at the top. Then size will be size is also 5, since 5 is greater than k. Um, then 5 will be removed, and then 4 is also greater than 2. 4 will be removed. Size is also 4, and
Hmm.
3, since 3 is also greater than 2, so 3 will also be removed. Then 2, since 2 is not greater than k, 2 is not greater than 2, this loop won't run, and then my priority queue will have the peak of 2, so it will return 2.
It will return 2. Yes, cool, perfect. So I'll quickly move to the next question, and this is a pretty simple question. You have been given a binary tree, and you have to
Okay.
revert the binary tree.
Okay. Uh,
Yeah.
Let me write an example. Uh, if I'm having, suppose 1, and then next children are 2 and 3. Um, okay, I'll use tab here.
Just I'm telling you the binary tree, just write it.
Okay.
So at
Okay.
the root it is 4, then 2 and 7 are its children. Then for 2 it is 1 and 3, and
Okay.
for 7 it is 6 and 9. Okay.
Okay. 6 and
So
9.
now
Yeah.
what happens when you revert is that the left things become the right and the right becomes the left. So 2 and 7 are
Okay.
swapped, and then 6 and 9, the whole tree, like the entire thing also comes to the left. 6 and 9 are at the right initially, they will come to the left, and also in themselves also they will get switched.
9 and
Got it?
6, right?
Yes. And on the right hand side it will be 3 and 1.
Yeah, something like this.
Just
Okay.
1 second, let me
This
check.
will be this will be 7, right?
One,
This will be
three.
7 and this will be
This
2.
will be 2. Perfect.
Yeah.
9, 6, 3, 1. Yes. So, yes, you have to do this.
Okay. 4, 3, 7. Okay, I have to like make the left subtree as the right subtree and right subtree as the left subtree, right? So mhm. I have to revert it, right? Not
Yeah,
check
you have to
whether it is reversed. Okay.
invert the binary tree, yes.
Yeah. Mhm. If I take a smaller, if I take just 4, 2, and 7, then I'll swap its left and right children. Okay. I'll also have to make the, like, I have to store the left children before taking right children to its place. I can do that. Hmm. Okay, so thing that is going on in my mind is like to ask the lowest parent to revert its. Uh, I'll use DFS. Okay,
Okay.
uh, like
And why are
traversing to
you
the
using
right.
DFS? Just tell me that also.
Uh, okay, so because I was thinking like I should ask four, like four go and ask your two to four go and ask your left child to invert all its children, right? And then I'll ask seven to invert all its children, and then I'll come to the root. So then,
Okay.
hmm, like I'm going in depth first,
Mm-hmm. Okay.
depth wise. Okay, so. Mm-hmm. Okay, just I'll see if these are. I have to store them. So if it is a binary tree, there will be just two children. Um, I'll ask two to do this. So I'll need a function for that. Like, okay, so if I'll start writing, I think I'll get that. Uh, so I'm supposing that I have to.
Okay,
Yeah.
firstly, it will be better if you can explain me like what, like how you're planning to do it, and then we will move to the coding part.
Okay. So sure. I will. I was thinking to go towards the right, uh, left part first, and then like what I'll do is I'll ask four, I'll ask two to invert its children. So I'll make another function which will take the left child and the right child and then swap their values. I'll not swap the links, I'll swap the values.
1 second. With DFS, you first reached 4, then you asked if it has a left child, it reached 2, then it reached 1, right? Now you see that
Yeah,
1
it
does
reached one.
not have a child.
Yeah. So since it doesn't, since it is the leaf node, I'll make it like I'll return from that,
Okay.
and then it will also check like three is leaf node or not, which is three is leaf node. So it will not do anything. Then it will come to two. Then I'll make another function, and since two is not a leaf node, what I'll do is I'll store its left and right child, and then swap their values, just the
Okay.
values, and then I'll ask seven, like four will ask seven to do so, do the same. So then six and nine will be
Okay,
reversed.
so you are saying that you will change the values. You cannot change the values. Like, you cannot change
Okay,
the
so
values.
I
Like,
have
you have
to
to
change the
change the.
links, right?
Yeah, yeah, yeah.
Okay, okay. Uh, and I have to return the tree node, right?
Yeah,
Root
you have to
node.
return the root node, yes.
Okay. I can't change the values. So I can go level order. I can use level order traversal. Um, okay. Then I have to write a function to build the tree also. This is not
No, tree
enough.
is
So
done for you. Just
yeah,
think like it is there for you. You just have to write the function.
yeah. Uh, okay, so rather than swapping the values here, which I'm not allowed to, what I can do is on reaching 2, I will store its left and right subchild, and then I'll make both of them as null, and then like I'm thinking of reversing the links here.
Okay, so you are saying that first of all you will go to the left part and then you will go to the right part, and what you will do is you'll make the left part as the right part and the right part as the left part.
Yes.
Basically, you're swapping, right?
Yeah.
Yeah, that is correct approach. But how are you going to implement it in the entire tree? Like, tell me that you're going in the right direction.
Yeah. So like if we take just 4, 2, and 7, okay. if I take just 4, 2, and 7, so I'll ask 2 that do you have any are you a leaf node? He said yes. I'll ask 7, are you a leaf node? He said yes. Then we'll swap the links, right? And then it will return me uh, 4, 7, and 2. Okay, so in this case, what I'll do is I'll ask 2 to do so, and I'll ask 7 to do the same. Then I'll ask 4 that now it's your turn, that your left subchild has an answer, your right subchild has an answer. Now it's your turn to do so. So,
Mm-hmm.
4, okay, I got your point. I need to store the whole subtree, right? Not
Yes,
just the
and
links.
as you're seeing from the
Okay,
example, like it is starting from the bottom, right? So as you
yeah,
mentioned earlier, also DFS, you were going the right thing. Like you have to start from the bottom, and then once you have done, like once you have swapped the bottom thing, then you have to move from bottom to up.
to the
Basically,
upwards.
yeah, think in that
Yeah.
direction.
Uh, yeah.
Yeah.
When I'm on 2, then I'll swap 3 and 1, 1 and 3. When I'm on 7, uh, I'll swap 2 and 9. Okay. And when I'm on 4, I can't do that because I have to store both the subtrees. Uh, like if I have to print it, then I can use the reverse order traversal,
Just think that
level
you have
order
to perform the
traversal.
same operations again and again. Like left, you have to like swap with right. Then again left, you have to swap with right. So there's a specific thing that we
Yeah.
use for that, if you can recall.
Yeah, like for 2, yeah, I get that. For 2, 1 and 3 will be swapped. For 7, 6, and 9 will be swapped. Then when
Hmm.
it comes to 4, what it'll do is it will store the 7 and 2, like swap the 7 and 2. Yeah,
Okay.
and like the links present in that will remain the same. But it will change. What happens when the link? I'm thinking. This is a
Yeah, take
new
your time, no
question
problem.
to me. Uh, when it comes to hmm, uh, change your values, change your left and right subchild. When it comes to 7, it will say change your right and left subchild. When it comes to 4, it will also say that. So what I'm doing is I'm taking mm, like I'm stuck on it because I was thinking that my approach, according to my approach, my like 7 and 2 will be swapped, but their subtree won't be like here 9 and 6 is coming here and 1 and 3 coming here. That won't be good. Let me turn it.
Just think in terms of recursion, maybe.
Yeah. Yeah, in terms of recursion, like I was still stuck on like 2 will do its job, 7 will do its job. When it comes to 4, um, 7 and 2 will be reversed, right? Yeah, so I won't store, I'll swap the links. I think it should work. Recursion should work.
Just try dry running. Like see what is not working, whatever you're thinking, what is not working in that approach.
Yeah, okay. Okay, I'm just writing a small piece of code to try run. node has my root dot left, and then what I'll do is uh, root dot left to root dot right, and then root dot right will be 10 or 10 not left. So here root dot left, that is 2. Okay, root dot left will store 7, and root dot right will store 10. I think it should work because like we swap like this. Uh,
Roots left, you have done to roots right. Yes, absolutely. And like whatever you
yeah,
have done is correct. Now, how will you move to the other parts of the tree? Now you have solved the left and the right. Now, how will you move to the other parts of the tree? So you can pass the same function again, like
yeah,
that is what recursion is.
yeah.
So you
For
can pass
the
the same thing
for
again
the
for
2,
left.
for the 7, and then for the root.
Yes, perfect.
Yeah.
So this is what recursion is. First of all, you have
Uh,
done the left and the right, and then you have to do it for
yeah.
other parts as well. So you'll pass the same function again.
Yeah.
Cool. So can you quickly code it?
Okay. Mm, let me take this node just to convert. Okay. Assuming that root is given to me. Mhm. I'll do is okay. I'll do helper. I'll call helper function for root dot left, and I'll call helper function for root dot.
But you have to pass the same function,
Yeah.
like invert only. What is the helper function doing here?
Yeah, I'll write that. In helper function, I'll check if it is leaf node, it won't do anything. Otherwise, it will swap.
Okay, just write the code, then we'll try run it afterwards.
Sure. Uh, it will be just void and helper function and node. Let me take it as node. What it will do is it will check if node dot left is equal to null and oh sorry. If it will check if it is a leaf node, then it will just return. Otherwise, uh, I'll store the left, then uh, I'll swap the value. No dot. Okay, mistake. No dot left will store. No dot right, and root dot right will contain temp. Okay. And here I'll check if root is null. I'll do nothing. I'll return null. Okay. So let me come. Oh, sorry.
Okay.
comment. Okay, this is not a code editor. You can ignore this. I'll remove this. Yeah, okay. So what this function will call the invert function. What it will do is it will check if the root is null. Since the root is not null, it will say that for call to, and to will do its work, that is helper root dot left, and when it will call the helper function. Uh, it will check that if it is a root node or not, if it is a leaf node or not. Okay, just a second. Since it is a leaf node or not, okay, then it will ask to reverse it, right? Then for the 7, okay, just a second. If it is, if one is also having some child, won't go there. Why so?
I think you're complicating it by making some other function. Like simple it is, just swap the values and then do the same thing to the left of the first value and the right of the other value. That is passing the same function to the left
Yeah.
and right again. So like I don't think helper function is required. Just like think about
Okay.
it. Hmm.
Um, okay. So if I won't take the helper function, then it will check if the root is null. Then it will swap, and then it will call its left. Okay. I need. I want that first left will do its work. Okay. Doesn't matter. Work will be same, right? So dot left, and my root dot, sorry, left will contain root dot right, and root dot right will be them. What will do is it will swap 2 and 7. Mhm. And then it will ask it's a left to do so, and it's right to do so. Ask it's left. So my tree will be 4, 7, 2. Mm-hmm. 4, 7, and 2, with the 7, 6, 9 is here, and 2, 1, 3 is here. And if sometimes root is null, it will return here. Yeah, this is true.
Okay, so you have stored the left and this, and then what you have done is you have passed the same function again, right?
Yeah,
Okay, cool. And what is temp? Okay, it
like,
is a temporary variable.
yeah, just a temporary node. So it will at the 4, it will first swap 7 and 7 right subtree and its left subtree, that is 7, 6, and 9 will come to right, and will
Mm-hmm.
come to left, and 2 and 3 will come to right. Then at the other level, what it will do is it will swap 6 and 9, because 6 and 9 will be at left. It will swap 6 and 9 amongst themselves, and it will swap 1 and 3.
Okay. Yeah, let me see if like all the other edge cases will also get passed. Um, and what are you returning finally? Yes, returning the root, right?
Yeah,
So yeah, I think this will work. So what would be the time complexity and the space complexity for this particular code?
mm, space complexity like will be nothing.
If you
We
don't
can say
consider the
constant, because
recursion stack, the space complexity,
yeah, yeah, for just there is just a temp.
right?
And for the time complexity, ask these two to do so, ask these to do so. It will be the O of number of nodes, because we are
O of n,
visiting every node once. Yeah,
right? And space complexity, what did you tell?
it will be constant, because excluding the uh, recursion stack, there is nothing, just a temp variable. So O of one.
Okay, O of 1. Okay, that is perfect. So, yeah. Thank you so much. Like, I think that was it. So, quickly, I will tell you the feedback, like, according to me. So, I'll start from the very beginning. So, firstly, I think the questions that I asked, I think the answers were not very appropriate. Like the functional components and the class components, if you're using React, I think that is one of the most important thing for a React developer, right? So that, yeah, you can stop
I
sharing your
can
screen.
like sure.
Right. Yes.
Yeah.
So that thing in the starting, so if you're a web developer and you're saying that you are working into React, so you should know these terms like props, hooks, functional components, class components, because these are the basic building blocks of that. Okay, apart from that, if
Okay.
I come to the question thing, so I think in the starting, did you know that question beforehand? Tell me honestly.
Which one?
The heap one.
No, no. I have done like there was a card of the heaps, right, in the lead code. So I was
Right.
reading that.
Mm-hmm.
Yeah. So I was aware
Okay.
of the heaps and hash maps also
Okay,
very
so
much.
like you jump to the optimized approach like immediately. So I think you should have started with some brute force approach and then slowly and gradually you should have moved to heap. So because you said heap
Okay.
immediately, I thought that maybe you have already seen that question. Okay. And the
Okay.
next thing was variable names. So this thing is one of the most important thing that जो कि सब लोग mistake करते हैं. So you took I, J, K. You should never use I, J, K in an interview. Like always use
Okay.
index or something that makes value. जैसे कि you used I and J for row and column. So you should have used row and column.
Row.
Right,
Okay.
row and column. So, and then in the first question, you did not ask me about the edge cases, right? So, as a student, you are expected to ask me if there would be any edge cases or not. Like in the second question, you address the edge case, like if there is no root given. But what if in the first case I'm giving you an empty matrix? Then what? Suppose M and N both are zero, then like
Okay.
that thing will fail. So like if you would have asked me, then I would have told you that okay, there will always be a valid matrix, or
Okay.
you should have taken some edge case wala thing, like if M and N is zero, then you will return
Yeah.
nothing, you will return null. So yeah, that was the thing. And yeah, apart from that, I think your explanation was good. I think you can मतलब थोड़ा सा think out loud कर सकती हो. Apart from that, like you dry run तुमने करा and then you were explaining things to me. So I think I was also understanding whatever you were explaining. So yeah, that was a
Okay.
good thing about it. Just variable names, please उसको ध्यान रखना.
Okay.
That is very
Sure.
important. Yes. So any questions for me?
Okay. नहीं बस लाइक एज केसेस वाला तो मेरे को बोला भी गया था, मेरा माइक्रोसॉफ्ट वाला इंटरव्यू था या
हम्म.
माइक्रोसॉफ्ट वाला ही था, तो उसमें मेरे को बोला भी गया था कि एज केसेस सोचो और क्या हो सकते हैं.
यस. यस, एज केसेस. और वरना आस्क द इंटरव्यूअर कि ये हो सकता है क्या, वो हो सकता है क्या, एंड वेरिएबल नेम्स तो बहुत इंपॉर्टेंट है. ऑल्सो योर इंटेंडेशन वाज नॉट वेरी गुड. लाइक समवेयर तुम ब्रैकेट्स भी हटा, मतलब यू डिड नॉट पुट द
हम्म.
ब्रैकेट्स एंड ऑल. तो
हम्म.
जस्ट मेंशन द इंडेंटेशन कि हर जगह
ओके.
प्रॉपर हो एंड एवरीथिंग, बिकॉज इन एन
हम्म.
इंटरव्यू जो हम लोग लीड कोड पे करते हैं जो इंटरव्यू में है, बहुत अलग अलग होता है, राइट? तो जस्ट
हाँ.
रिमेंबर दोस पॉइंट्स, अदरवाइज यू वर गुड. Like it was
ओके.
nice interviewing you.
ओके.
Okay,
थैंक यू.
thank you so much for joining. Thank you so much for joining. Bye bye.
थैंक यू. बाय.
So, yes, guys, this was the interview. If you guys also want to give mock interviews, you can fill the form that is there in the description below. And I will see you in the next video. Bye bye.